So lab this week, we're gonna be doing another sketch. I know our second lecture material here to this week was or is also a drawing lab. In this case, what we're gonna be doing is I want to do something slightly different. So the second lecture video this week was on a simple cylinder circuit, and you drew out the power unit. So this one will be similar. What I'm gonna get into this week, and it'll be actually in starting Monday. Well, I guess next Monday. Since this is technically our lab this week, I guess you guys will be online next Monday. But starting Tuesday of next week, those with labs will be back in lab. So I'll be back in lab next Monday, and back in school next Monday after this quarantine period. But this is going to be our lab for this week. So I want to do a couple drawings, and what I'd like you to do is follow along and basically submit your images after you've done and actually drawn everything out. What I would suggest you doing is using a pencil. I'm using it this way. I've tried to do it with my dock cam, and I'm going to try it actually with my tablet this time. Maybe it'll work out better. I can erase, won't be using up paper. So if you have any questions on this, please do let me know. We will be getting more into schematics here in the coming weeks. This is a little bit earlier than what I usually get in with the schematics, but again, it's something we're going to be using all semester, so getting into it early isn't necessarily a bad thing either. So I'm going to go through and we're going to draw our power unit first. Okay, so the first thing I'm going to draw here is the reservoir. Oh, and for some reason that's red. So first thing I draw is really the reservoir here, and then what we get is you're pulling your hydraulic oil from your reservoir, and that's going up to your pump. Pump is a circle, and then you have an arrow pointing in the outward direction. Within your power unit itself, there's a pressure regulator. This is how we change, say, from going from 20 psi or 0 psi to 500 psi. So what we're actually adjusting here is a spring pressure. And we'll talk more about pressure regulators as we get into the semester. But what they are, you draw a rectangular box. Oh, I thought maybe I could zoom in. I'm not as big of a fan of this whiteboard, but it does allow me to point. So there's one positive, I guess. So what we have here is an arrow. And notice how it's not connected. Because we have what we call pilot line. Come here, and as pressure gets created in this line, it's going to slowly open up the valve, and any excess oil, hydraulic oil, will go back to the reservoir. And on the other side, this is where the spring is. So this is basically what pressure is pushing up against to move that arrow in line with your working line. So this is really your spring that's causing that, and usually there's an arrow that goes through this that depicts that is adjustable. And that didn't come out very clean, so let me just redraw quick. So we got spring, and then just a quick arrow pointing through that just means it's adjustable. So we can change the pressure by turning a knob. Another thing that's on our power unit is a pressure gauge, right? So we have a pressure gauge that's a circle with this arrow. Sorry for my weird shapes here. I'm trying to draw circles. But that'd be our pressure gauge. A lot of times, what I like to call these is kind of like a lollipop, right? So you got your lollipop shape, and then you just draw an arrow within that, and that's your pressure gauge. And usually, for our power unit here, we would call this, for our lab gauge, S. So our gauge, when it says to turn gauge S up to 500 psi, they're talking about adjusting this pressure regulator to where our gauge S shows 500 psi. Alright, as we move out from our power unit, we go into the system. The system for our setup here, for our hydraulic lab stations, we have our working line comes over, and we have a manifold. So that manifold typically has a shutoff valve, and then you have multiple hookups. I think we have 4 hookups. So technically there needs to be more there. So that's really our manifold. This is where we hook up multiple lines to our power unit itself. And before we get to that manifold, typically there's something in this line. That's nice. That deletes the whole line. There's this thing that I like to term the bow tie. Basically, what that is, it did not come up. Oh, like, whoa. This is a shutoff valve. So your typical on-off ball valve looks kind of like a bow tie. And in lab, that's our yellow handle that's on our manifold that we can turn on and off our system. And again, I know we haven't really used that yellow handle yet. That was going to be what we were doing this week. Right now, I'm just going through some of our standard setups that we'll see actually. So in this case, for this drawing, we'll hook up a motor control, so hydraulic motor, and they're just as easy as our hydraulic cylinder lab that we also drew for lecture 1, or well, lecture 2, week 2, lecture 2 this week. I had you draw a basic cylinder circuit. This one here is going to be our basic motor circuit. So typically with a motor, we want control of, say, forward, reverse, and stopped, right? So we're going to use our directional control valve, and a lot of times I like to draw this before I do the hookups for it, so I'm going to kind of draw it off to the side here. And you draw a rectangular piece. We need 3 squares inside this. The 3 squares represent the number of positions. As I mentioned before, we have start, stop, and off, or forward, reverse, or off. So if I was drawing this by hand, I would suggest pencil. And then you can always go over it with marker afterwards if you're having a hard time visualizing it with your camera. The ports on this, so in this case we're going to have 4 ports, and the reason is because we have an inlet and an outlet, and then we have to connect to either side of our cylinder or a motor. So we have 3 positions here, 3 boxes, and we have 4 ports. So this is, you know, basically what's called a 3-position 4-way. So we have 1, 2, 3, 4 ports, hence the 4-way term there. So it means fluid has 4 ways to go, but has 3 positions. So I'm going to just hook that up to this, and a lot of times you'll see something called a P and a T on your valve systems. The P is your pressure port, so this is where we're sending pressure to the system, and T is going to go to our tank, so right back to our reservoir. And a neat way to go back to your reservoir without having to go all the way back to this main reservoir that we drew initially is just to say, all right, goes back to reservoir. That's just a quick way to say it goes back to reservoir. It doesn't necessarily mean you have multiple. No, it doesn't mean you have multiple reservoirs. It's just a quick way to keep the drawing from getting messy if you were to draw all those lines going back to the reservoir. Sometimes we'll have a drain line, sometimes we'll have a bleed off line, and you know those all go back to the reservoir. But rather than again drawing these lines that get squiggly and messy, it makes it hard to follow. So this is just a quick and easy way to say going back to reservoir. All right, so our positions, what they provide us is straight through. So in this position, we get our pressure port connected to, I'm going to term port A. This is going to be port B down here. So that allows fluid to go straight through. And then on the opposite side of that, we go to the tank. So pressure goes through, say turns our motor, and then goes back to tank. Our third position here is going to be a crossover. So our pressure is going to go to port B, and port A, fluid going through port A is going to go to our tank. So essentially we switch directions. So we'd have kind of forward direction and then our reverse direction, and then what we call the center position here. A lot of times we term this the normal position, because why they term that way is when the system is off, or termed what is the normal position, is what is the position of the valve when the system is shut down. So that's your normal position. And typically your normal position is going to be the center for these 3-position valves. And you're going to have different centers, open center, closed center, tandem centers. And we'll go over each one of those when we get into directional control valves a bit more. But what you end up seeing in a lot of these schematics is they'll show a spring on either side, like this. And what that signifies is, well, when we're not actually moving the lever, we let go of the lever, those springs center us back to our normal position. So this is what we term the directional control valve, DCV. Alright, so our directional control valve is going to be powering our motor. So a lot of times what I like to do, erase those extra, my hand touching the screen here. What I like to do is I like to draw my components, and then a lot of times I'll finish the wiring after I get the components drawn. So we have another circle, more or less, and in this case it's going to be slightly different than our pump over here. So the pump, we had a circle, we had an arrow pointing in the direction we're sending fluid. So this gives us, the direction, pump output going through here, going to pressurize this line. Once the ball valve's open, pressure will come in through here into our system. In this case, our pump is different than our motor because our motor is going to be bidirectional, meaning it can go forward or reverse, right? And the way you do a motor is where you put your arrows and where you're pointing your arrows. So for instance, this one here, both arrows are pointing inward. meaning the fluid is pushing the device. So the arrow is on the inside pointing toward the center of the circle, right? If you notice, this one is pointing outward away from the circle. So those are your big indicators on, do I have a pump or do I have a motor, right? So this is our motor. Let's see, motor. This is our pump. This is our relief valve. Ball valve. Also known as shut off. Shut off valve. Or ball valve. And this is our manifold here. Just to review those components. So those, hopefully they're legible or readable here. So now we want to hook up the motor. Well, say we needed to control the motor. Say we wanted it not to go as fast as, say, the max pump output. Well, how do we control a motor? Well, we need to control the amount of flow going through the motor at any given point in time. So we have, say, our forward direction. We come out of A, and we want to connect it to one side of the motor. B gets connected to the other side of the motor. So if we want to control flow rate, forward, reverse, both directions. We'll talk about flow control more in a later lecture. But basically, the most simplified way to control speed is going to be using a needle valve. Or basically, your simplest flow control valve is going to be a needle valve. And the needle valve is pretty simple. It just looks like that. And if it's adjustable, so again, you have a knob where you can open and close how open or close the needle valve is. It has an arrow through it. So basically, this shape here is kind of signifying, all right, as we pinch or open it, we're going to be changing the orifice, right? And again, the arrow is just saying it's adjustable. If it didn't have this arrow, that would mean it's not adjustable. And typically that means you have a fixed orifice valve or something that's controlling the flow through that given point. So this is needle valve. Also known as our flow control. Again, we'll go over more flow controls, various different pressure controls. All that's the plan all semester, really. This video here kind of to get you into the graphic symbols of everything, starting to get used to how they get laid out, start getting used to drawing these. I know I get a little flag every semester. Students are kind of hesitant to do the drawings, or I'm not great at drawing. I understand that some of you may not have done much drawing as you're growing up or don't like to draw. This isn't just art as we're doing it. This is meant to be simple enough to where if you take your time, it isn't that hard. So it doesn't take that long. It really isn't that hard. If you notice here, they're all simple shapes. I know obviously my squares aren't the best. Circles, I did the best I could with the tablet. But basically, do your best. I would suggest, you could be at least this neat. It'd be great. If it gets any messier and it's hard to read, it's kind of hard to grade. So, um, getting used to drawing these out, the simple shapes. You got rectangles, triangles, squares. It's all simple, basic shapes. Just take your time, draw them out, and if you need to, again, erase and redraw. That's why I would suggest using pencil. And that's kind of why I really wanted to use this tablet, is so if I made a mistake, I can go back and erase and tweak it. It's really difficult if you do it with pen or marker. Those scribbles can really throw off a person's understanding of what's happening in the circuit. So if I just took this and I had one of those in there for some reason, that doesn't really help whoever's trying to figure out what's going on with the circuit. So being able to fix your drawing, erase, rather good strategy to use. Be used to using pencil. I guess be ready to use your eraser, really. If you have any questions or concerns on the setup here, let me know. We'll be hooking up a motor circuit, not this upcoming week, probably the week after. We'll see what we can get through in the next week or so after this online session here. It's going to push out some of the labs, but I feel like what we can do is I can condense some of the labs, and we can fit more into one of these sessions and jump into the next kind of more meat of the course. The relief valves, the flow control valves, understanding directional control valves, and so on. So that's really the plan from here on out. Again, I would like you to draw this out as I have. I would also suggest labeling your components just as practice, right? So this is another reservoir. That's also the reservoir symbol for turn to our reservoir. I think I spelled that reservoir. So again, this is kind of messy. Sorry about that. But that's what I'm looking for. So if you could label it, take your time, draw it, take a picture, and upload it to our lab assignment this week. So I'll put it up as it'll be in a learning module, and then it's going to be in an assignment. So for instance, let me show an example here. We'll go to, say, 149, for instance. So 204, you guys will have a very similar situation here, but you're going to have, actually, I guess I'll go 204. I think I have it set up in there. Nope, guess I don't. But basically, it'll be kind of like your intro to hydraulic graphic symbols here. So this is that week 2, lecture 2 initial drawing that we did. So you're going to go in, draw up the schematic, and you're going to go into the assignment. So you have to click on the title here, and then browse your local computer, find the image that you took of your circuit, and upload it, hit submit. But that's how you do your submission. If you have any questions or concerns, or again issues, can't figure out how to do the submission or how to submit, let me know. We can meet over Zoom. I can share my screen, show you again. You can share your screen and show me, if you're having issues, what you're seeing. But that's the best way to work through it this week. If you really can't get it on and you're still having troubles and you're still struggling with getting it in, we can meet next week during our on-site campus lab, and I'll bring my computer. You can show me what you're having difficulties with, and we'll get it figured out there. All right, but that's it for lab this week. That's the plan for really our lab. So go through, draw that, label them, and submit. All right. Well, hope everybody is getting started well with their semester. Hope you're all staying safe and healthy. And I'll see you all next week. All right. Later.